This particular video supports figure 2.6 in the chapter on hearing. The figure helps us to understand the cochlea. Most people would be totally unaware of the cochlea, yet this structure is responsible for you and I to be able to hear speech, music, and all the wonderful and less wonderful sounds that surround us. The structure and function of the cochlea is a little complex, so there are two videos on the subject. This video is figure 2.6a and 2.6b will follow. These three illustrations look in successively greater detail at what's inside the cochlea and to understand how sound is converted into signals that the brain perceives as hearing. By way of analogy, imagine looking at the workings of a piano. We would first look at the whole piano. We could look at its shape and form and enjoy listening to someone playing the instrument. But just by looking at its shape, we wouldn't know how it produced its incredible sounds. In order to understand how it worked, we would have to open the lid, separate the component parts, and probe its mechanism to see how it produced its wonderful notes. We would then get to its basic mechanism for producing music, that is, the workings of each key of the piano. The cochlea is far more complicated than a piano, of course, but we can still get to grips with how it works through a similar approach. Grappling with how the cochlea functions is well worth the effort, as you'll discover the beauty of an amazing system that allows us to hear voices and music in enormous detail and clarity that helps us learn about others and about the world around us. The cochlea is essentially a tube that is coiled roughly 2.5 times. If we were to uncoil and straighten the cochlea, we'd see something like this long tube. The reason the cochlea is coiled is to make it compact to fit into a small cavity in the skull. Throughout the length of the cochlea is the basilar membrane. The reason we can hear different frequencies of sound is because of the properties of the basilar membrane. Near the base end, the membrane is narrower and stiffer, making it more responsive to high frequency sounds. Towards the apex end, the membrane is wider and more flexible, responding better to low frequency sounds. Between the two ends, there is a gradual shift from one frequency to the other. This diagram shows a side view in cross-section through the uncoiled cochlea. Inside the cochlea is a fluid formed from cerebrospinal fluid, CSF, in the brain. Sound waves entering the middle ear cause the stapes to vibrate, setting up pressure waves in the fluid. The pressure waves cause the basilar membrane to vibrate. Along the basilar membrane are motion-sensitive receptor cells that detect the vibration of the basilar membrane and produce nerve signals that are sent to the brain. The next video explains how this occurs. To prevent excessive pressure building up in the cochlear fluid, the flexible round window bulges to accommodate pressure changes. Please now look at the next presentation, figure 2.6b, for the next part of this story.